Hi everyone, now we're going to be talking about graphing exponential equations. So like we've talked about in a previous video, the general form for an exponential equation is y is equal to a times b to the power of x. When we're graphing them, that a kind of represents the y-intercept. It's where we started off. And then the b isn't necessarily the slope, but it does show us the rate of change, or how much it's growing by, or how fast, by how do I say this? How fast it's growing. Now, when b is greater than 1, or when b is a whole number, that means that it's a growth equation. And so when we have growth equations, they start out really slow around 0, and then they go up and up and up really fast, like that. And then then decay equations is when b is between 0 and 1. So b can't be a negative number. It will not work. It'll always be either a fraction that's less than 1 or a whole number that's greater than 1. And so if it's a fraction, or that b is in between 0 and 1, then it's considered a decay equation, which just does the opposite. So it starts out really big and then it drops down really fast. So those are my two different types of equations. Now what we're going to do on these examples is first we're going to graph some, and then we're going to determine what the equation is from graphs. So let's start with the first example. The first example is y is equal to 3 times 2 to the power of x. So like I said, this 3 is like your a, and then the 2 is like your b. And remember, I told you that the a is kind of like your y-intercept. So I'm going to start at 3. I know I'm going to put a point right there at 3. Then from there, that 2 represents how fast I'm changing. So what I'm going to do is take my y-intercept, which is 3, and I'm going to multiply it by 2. So 3 times 2 gives me 6, which tells me that when I move over 1, I'm going to multiply by 2, and I'm going to get to 6. Then if I wanted to put another point there, I would take 6 and I would multiply that by 2. So 6 times 2 is 12. So I'm going to go up to 12, 7, 8, 9, 10, 11, 12. And then I'm going to go over 1 more on the x-axis, but then put a point at 2, 12. Now I can do this backwards too. So I started on the y-axis at 3, but now I'm going to go backwards 1. So instead of multiplying by 2, I'm going to divide by 2. So 3 divided by 2 is 1.5. So I'm going to find 1.5 and put that point there. And then I can do it again. If I move over again, I'm going to do 1.5 divided by 2. 1.5 divided by 2 is 0.75. So I'm going to find that point right there. And then I could continue to divide by 2 or multiply by 2. But what I'm going to tell you is that it will not go past 0. That's one of the cool things about exponential graphs. It doesn't go past 0. But it'll get really, really big. So the whole graph kind of ends up looking a little bit like this. Okay, so now let's go to the next example. The next example has an extra thing right here, this -1. So this -1, if we remember back to the transformations of graphs lessons that we had, the -1 will drop everything down 1. So the easiest way to do this one is to actually just graph this portion of it, and then take the entire graph and shift it down 1. That's the easiest way for me to do it. So let's do it that way. Because this will be your a, the front number, and then that 1/3 will be your b, which means that for your a is 4, I'm going to start at 4. So I'm going to put a point right there at when y is equal to 4. Then because that b is 1/3, instead of getting bigger and bigger as the graph goes to the right, it's going to get smaller and smaller. So it's going to look opposite of what that first example looked like. It's going to be, it'll start big and get small. Because what's going to happen is now if I move 1 to the right, I'm going to multiply the 4 by 1/3. So 4 times 1/3 is 4/3, or 1.3, which is about right here. Then if I do it again, if I want to go another one right, then I'm going to take that 1.33 and multiply it by 1/3. And again, and then I get like 0.44, which will be another point like right here. And I could continue. It's going to get smaller and smaller, but it'll never hit 0 like we talked about. And then let's go opposite now. So instead of going to the right, I'm going to go to the left one. So I start at 4, and instead of multiplying by 1/3, I'm going to divide by 1/3, or the opposite of that, which is multiply by 3. So I'm going to do 4 times 3, which gives me 12. So I'm going to go up to 12 now. So 5, 6, 7, 8, 9, 10, 11, 12. And then I can put a point there. And potentially if I wanted to move one back, again, I would do 12 divided by 1/3, or 12 times 3, which gives me 36. That's way too big for my graph, so I'm not going to do it. But we do get the gist of it with these points, so I'm going to just draw this graph, and this is kind of what it looks like. All right, now that was just dealing with this portion like we talked about, but now we have to deal with this -1. Because of that -1, it shifts everything down 1. And so I'm going to do it in red, just so you can see it on the same graph. I'm going to just drop this guy down 1, 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 and it all ends up kind of, obviously it looks really similar. It'll just go below 0 slightly because we had to drop everything down 1. That's the only time it goes below 0, is if you have that extra chunk right there, the extra like -1 or whatever, minus some number right there. If it was a plus number, then instead of shifting it down that many, you would shift it up that many. All right, cool. So let's now look at some graphs that are already made for us and write equations for them. So we know that the form of an exponential graph is y is equal to a times b to the power of x. And the a is kind of like our starting point, or our y-intercept. So I know I'm not the best artist, but you can look at your example sheet, and the first thing I'm going to do is find a. A is where we start, so in this case it's got to be 5. Now to find b, we're going to kind of do it the way that we were graphing them. I know I start at 5. So I'm going to find another point on this graph where it crosses the grid exactly. And one of those points is -1, 10. So if I went from 5 to 10, then that means I multiplied by 2, right? But I went backwards. So instead of multiplying by 2, I'm really dividing by 2 because I'm getting smaller and smaller. So that tells me my b is 1/2. Again, I know that that's 1/2, first of all, because it's getting smaller as it goes to the right, and also because I'm going from 10 to 5. Or I started at 5, and if I go backwards, I got to 10. Which means my final overall answer is y is equal to 5 times 1/2 to the power of x. That is my equation. Now, if that is a little bit hard for you to understand, we can always do it with like writing exponential equations, which is what we're going to go over in the next video. So if you feel like, hey, I'm not super sure about how to figure out the b, or the rate of change in these things, I want you to skip over to the 11.6 video and watch that. And then potentially you could use the 2 points. So like in this case, our 2 points were 10, -1 and 5, 0. And then you can write the equation that way. Once again, that's only if you still don't understand after this video. Okay, so let's go to this one. This one is a little bit harder. This one's going to have an extra number on the end of it. And the reason why I know it has an extra number on the end of it is because if you look at it, instead of stopping at 0, like getting really, really close to 0, it gets really, really close to 1. And so what that tells me is that everything got shifted up 1. I know there's going to be an extra +1 at the end of the equation. Because again, the line gets really, really close to 1 instead of really, really close to 0. So, with that kind of +1 in mind, we're still gonna, if I know everything shifts up by 1, that means instead of having the y-intercept as 3, which it is now, the y-intercept will be 2, because remember, everything got shifted up 1, so instead of starting at 3, I actually wanted to start at 2 if I didn't have this +1. So I know that my a is equal to 2 in this case. The other thing to kind of think about too on this is even if you couldn't recognize that, or if you're like, oh, I didn't know that there was supposed to be a +1 there, notice that so we start at 3, and then the next number, like the next point where it crosses the grid exactly, is at 7. So to get from 3 to 7, I have to multiply by 7/3, which is not a real awesome B. I'm going to tell you your B's are really pretty numbers, like 2, 3, 4, 5, or 1/2, 1/3, 1/4. It's not going to be 7/3. So if it doesn't make sense to jump from 3 to 7, like what do I have to multiply to jump from 3 to 7, then you know that it's got to be shifted. Instead, because I'm shifting everything down 1, I'm going to jump from 2 to 6. So to jump from 2 to 6, what do I have to multiply by? Well, that makes a little bit more sense because to go from 2 to 6, we multiply by 3. And so that tells me that my B is equal to 3. And so I know the front of my equation is y is equal to 2 times 3 to the power of x. And then I'm going to tack on that +1 because everything got shifted up 1. All right, and there we have it, how to graph exponential equations.